You know what is differential equation? Okay, see. Yeah, dy by dx is called first order derivative. Okay, dy square upon dx square is second order derivative. This is third order derivative. Yeah, this is nth order derivative, right? So when the equation comes in the form of dy by dx are in this form, it is called differential equation. Okay, for example, this is quadratic question, right? But let's suppose this is not a quadratic equation. This is second order differential equation. Okay. Why? Because this is equation in the form of differentiation. Right. So this is called differential equation. Understood? Equation with differentiation. Okay. So now I tell you uh, how to form a differential equation. Formation of differential equation. Okay. Let's suppose y is a function contains an arbitrary variable. Sorry, arbitrary constant. Then differentiate y n times. Okay, and eliminate the constant. Okay, what does it mean? It means let's suppose y is a function of 3x square. So you can see the, whenever a function y contains an arbitrary constant. What is constant? Let's suppose this is a function of y. Here one arbitrary constant a is what? Constant, and this constant is for arbitrary constant. So this function contains how many constant? One. So the number of arbitrary constant is one. So we have to differentiate this y one time only. Okay. And you know when you differentiate y, you will get dy by dx 2ax, right? Okay. And after this, what you have to do? Eliminate the constant. It means that you have to remove the value of constant. No, no, no. Differentiate, don't differentiate again. You have to differentiate only one time. Okay. From, let's suppose from the original equation, you are getting the value of a, right? Put here. To value of a is into x. X cancel. Multiply x on both sides, we get what? 2y, right? Yes. So we get this is a differential equation. Okay. Yes. After cancelling out, I have multiplied x on both sides. So how can you get a differential equation? Just do only one thing. Count the number of arbitrary constants and differentiate the number of arbitrary constant एंड एलिमिनेट द आर्बिट्रेरी कांस्टेंट. हमको क्या करना है, उसको डिफरेंशिएट करना है और जितना भी आर्बिट्रेरी कांस्टेंट है उतनी बार डिफरेंशिएट करना है. राइट. अंडरस्टूड. कैन यू मूव?
Yeah.
यू कैन नोट दिस.
क्या?
नोटेड.
Yeah, got it.
कैन यू टेल मी हाउ मेनी आर्बिट्रेरी कांस्टेंट आर देयर?
There's
One. So differentiate this equation one time only, right?
2x plus 2y.
Zero.
0.
And it automatically remove, right?
Yeah. So dy dx. 2y
Yes.
dy dx equals x over.
You can add x over y. This is your differential equation, right? Understood?
Yeah.
Okay. Tell me how many constant are there? Two. So how many time you will differentiate it?
2
Two times, right?
dy dy. Dx equals negative base 19.
This is your first equation, right? When you differentiate first time, you will get,
Negative base 17
yes, very good.
plus b 20. And for negative base cosine negative side.
Okay. In this, when you take common, you will get, right?
Wait, the variables are different. Oh, it's an x. So
Yes. And you can see from first equation, the value of y is,
it cosine.
so same thing,
Mm-hmm.
right? So you can write here minus y, right? Now you can see automatically constants are removed and you get this differential equation, right? Note this.
Yeah.
Right.
Yeah.
Can you try this?
Cosine of it's two squares. dy
There are two arbitrary constants. So how many to differentiate this?
two.
When you differentiate first time, what is derivation cos log x? Negative sin log x.
Log x is equal to
Yes. Right. By using chain rule,
yeah.
cos log x into 1 over x, right? Isn't? Yes. Take 1 by x common, or you can say multiply x on both sides, right?
Yeah.
One more time you have to differentiate this because there are two
So
constants.
it's x d squared by dx squared.
Yes.
So
Here left hand side you have to use chain multiplication rule,
product.
product
Yeah.
rule,
X d squared by d dx.
and derivation of x is 1. Here a sin
So it's
sin becomes cos.
negative three.
Again take minus 1 by x common, right? Okay. And this is what? This is same thing,
Mm-hmm.
right? So you can replace there y.
Yeah.
Now you can see your arbitrary constant removed now, right?
Wait, isn't log x?
ln 10.
Yeah. The log x should be 1 over. log x will be written log x will be written ln x over
Whenever log is
yes.
given, its base is automatically e. So when you write the derivation of log x, it is what? L 1 over x ln e. Ln e is 1, right?
Space would be tan.
Okay, when tan ln means log to the base e.
Yeah.
Tan is not given.
No, when log x is
Yeah,
automatically one.
yeah. Actually this is not log. This is ln. Okay. So whenever you get log without any base, always consider ln. Okay. Yes.
Okay.
Done.
It's one constant.
Yes. Q is the constant. So anyhow eliminate Q by differentiating one time only.
dy over
Yes.
limits
Yes. Let's try this. This is very good question.
dy over dx equals negative sin. That's why
This is negative sign x plus q, right? Now you differentiated one time. Now still it is not
elimination.
eliminated. And how? What will you do?
Replace cosine inverse y.
No, no, no. You cannot differentiate further because the rule says that number of derivation depends on number of constants.
Yeah, no, I said negative sin cosine.
So sine inverse y.
Because x plus y, q is cosine inverse y.
So sine inverse y. No, no, no. See, see one thing. Do square on both sides. right? It becomes what? Sin square theta. You know sin square theta is? Very good. Anyhow, try to change thing into first form so that you will get y, right?
1 minus y squared.
Very good. This is your differential equation. Okay.
Mm-hmm.
Yes. Note down this.
Okay.
Can you tell this?
Mm, ELN is just tan inverse x, y equals tan inverse x, right?
Yeah.
And then there's no constant in that.
Yeah. Here is constant m.
But that's M. Oh, I thought that was LN.
No,
Oh,
no.
my bad.
This is
Uh,
m. Any constant.
so there's one constant. So dy dx equals e to the power m tan inverse x times tan inverse x times sec squared x.
No, no, no. It is 1 plus x square.
Oh, yeah, wait. 1 over 1 plus x squared.
Tan x derivation is sec square x.
Mm-hmm. So dy dx equals e to the power m tan inverse x times m times 1 over 1 plus x squared.
Right?
And so y is just dy over dx. Oh, wait, but we have to take the m out. So
Yes. You have to eliminate m anyhow. Suppose you replace this with y. No doubt.
yeah,
But still m is there. Right?
yeah.
What can you do now? But you cannot differentiate further.
Yeah.
Think. I tell you. Think 1 minute. Not getting?
I'm thinking.
Find the value of m from original equation by using
That's
logarithm.
ln y divided by tan
Yes.
inverse x.
Okay. Take ln on both sides. You will get what? M tan
ln y
inverse.
equals
Yes.
m tan inverse x.
So you can say m will be
Ln y divided by tan inverse x. I thought of doing that, but then I thought that solution would be too complicated and there would be a mess.
no problem. When you have no option, so this is the last option.
Okay.
Okay. So finally, m into y. So when m is multiplied, you will get ln y tan inverse x. Okay.
Mm-hmm.
So denominator is shifted to left side. Okay. Either you can
Mm-hmm.
write in this way or in this way. This is also differential equation. Okay. I
Mm-hmm.
did cross multiplication. So this is multiply with here left side and
Yeah.
this is multiply with right hand side. Okay. Otherwise you can
Mm-hmm.
leave here. Understood?
Yeah.
Yes.
Okay.
Okay. Done?
Yeah.
Okay. Up to now you have learned how to form a differential equation, right?
Mm-hmm.
Now you will learn how to find the solution of differential equation. Solution of differential equation means suppose dy by dx is equal to e raised to x minus y is given. Then what is the value of y? Okay. पहले y देता
Mm-hmm.
था a function. We formed a differential equation. Now a differential equation is given. You have to find the value of y. Okay.
Okay.
So this is called solution of differential equation. So basically there are 6 type of solution you have to study, and then your chapter will finish. First method is called variable separable method. तो पूरे तुम्हारे चैप्टर में यही सब टॉपिक पढ़ने हैं. व्हाट आई एम टेलिंग यू राइट नाउ. होमोजीनियस मेथड, नॉन होमोजीनियस मेथड, फोर्थ इज एग्जैक्ट डिफरेंशियल इक्वेशन, नॉन एग्जैक्ट डिफरेंशियल इक्वेशन, सिक्स्थ लीनियर डिफरेंशियल इक्वेशन.
Wait, differential equation का solution क्या होता है?
ओके.
जब integrate करते हैं?
You cannot integrate directly, but you have to find the value of y such that dy by dx holds its solution. जैसे देखो तुमने क्या किया, जैसे ये था a cos x plus b sin x था, राइट. इसका तुमने डिफरेंशियल इक्वेशन बनाया तो क्या मिला? ये मिला ना,
Yeah.
राइट। नाउ अब तुम्हें ये दिया जाएगा क्वेश्चन में, इस बोलेगा फाइंड द सॉल्यूशन ऑफ दिस। सॉल्यूशन ऑफ दिस मतलब इसका y का वैल्यू क्या रहेगा, फंक्शन क्या रहेगा, राइट।
Mm-hmm.
वही हम लोग को फाइंड करना है बाय यूजिंग दिस मेथड। तो ये मत सोचना कि डायरेक्टली इंटीग्रेट कर दिया तो वी गेट द आंसर, यू कैन नॉट इंटीग्रेट डायरेक्टली, राइट।
Yeah.
ओके,
But like it's like sort of like integrated.
या integrating is there but directly integration is not there, there are some rules to integrate this, okay। तो वो रूल एक एक करके
Mm-hmm.
हम लोग पढ़ेंगे।
Oh, okay.
So note this method, I explain first one। Done noting?
Yeah.
Okay, done, can we move?
Yeah.
Okay, so first method we will discuss। First method is variable separable method, okay। As the name suggests, variable separable method, it means that you have to separate the variable according to dy dx। मुझे क्या करना है, if dy by dx is given, तो यहाँ लेफ्ट हैंड साइड में रखेंगे एफ वाई वाला फंक्शन और राइट हैंड साइड में रखेंगे जी एक्स वाला फंक्शन, ओके।
Mm-hmm.
वेरिएबल को सेपरेट किया, देयर आर टू वेरिएबल, एक्स का वेरिएबल और वाई का वेरिएबल, तो वाई वाला एक साइड करेंगे और एक्स वाला एक साइड करेंगे, ओके।
Mm-hmm.
एंड देन वी इंटीग्रेट, and whenever we integrate always add one constant, okay। हाँ, for example, if I ask you solve dy by dx, solve, solve means find the solution of this differential equation, right।
Mm-hmm.
What will you do? First write the equation, can you write in this way, e raised to x e raised to minus y, okay।
Mm-hmm.
Okay, now this is what function of x and this is what function of y,
Yeah.
okay। तो सेपरेट, मैंने वेरिएबल को सेपरेट किया अकॉर्डिंग टू देयर वेरिएबल्स। तो dx को मैं इधर भेज दूंगा बिकॉज ex इज देयर, एंड y को इधर भेज दूंगा, राइट।
Mhm.
Again, you know, whenever denominator is negative, you can make it positive by shifting it to numerator. Can you do in this way?
Yeah.
After this, do integration. You know, integration of y is ey, integration of ex is ex, and there is one constant. This is your different. This is your original equation. Okay.
Mhm.
And suppose you want the value of y, take log on both sides. So y becomes ln ex plus c. This is your solution, right?
Mhm.
Understood?
Okay.
You know Parag Agrawal?
Radha Agrawal? No.
You don't know Parag Agrawal?
No.
Really?
Parag? Twitter CEO?
Yeah, yeah.
Yeah.
Okay. I asked randomly. Don't worry.
I think this method was like we learned it in single variable calculus too.
Yes.
Or like we got the intuition of it.
Yeah. These are very helpful when you read further, when you study further for linear differential equation, Bernoulli equation.
Okay.
Okay.
Mhm.
Okay.
So the main purpose of solving a differential equation is to make it in terms of the variables that are not differentiated.
Yeah. Okay. Okay. Now see this question. You can see variable is separated very easy, right?
Mm-hmm. Oh, x squared plus 1 dx.
Actually, here dy and dx is there. Okay. Now, when you
Oh,
see y square plus 1 always with dy, and
1
this is what?
over x squared plus 1.
Right?
Yeah.
Now,
Integrate and you get y cubed over 3
yes.
plus
Okay. Now, left hand side will integrate according to x
y.
y cube plus 3
Yeah, plus y.
plus y.
Plus,
And this part,
this part we have to do I. So we have to take tan inverse x as u and
yeah,
1 plus x.
by using substitution method. Let's consider u is equal to tan inverse x. Then du becomes
1/1 plus x squared.
yeah u du, right?
Oh, so it's tan inverse squared
Yeah,
x
u
over
square
2.
plus c.
Tan inverse squared x tan to the power negative.
Don't write here minus 2. Okay, there is no concept of minus 2.
We have to divide tan inverse squared by.
Yes, this is your answer. Yeah, 2 will be there. Okay,
Mm-hmm.
yes.
Yeah.
Okay. Sometimes variable separable method is not used directly. We have to reduce into variable separable form. For example, this is called reducible to variable separable. Okay. For example, if I ask you, okay, you cannot separate y, x individually, right?
Mm-hmm.
So what will you do? In this case, you have to consider this as a one other variable. Let's suppose this is t, or you can consider u, any variable you can consider other than x or y. Okay.
Okay.
Now find dt over dx. dy dx is 1, dy by dx is plus 0, right?
Mm-hmm.
So from here you will get dy by dx will be what? dt by dx minus 1. Okay.
Mm-hmm.
So I can write this original equation into, this is the equation first is called original equation. Original equation becomes what? Is equal to t square, right?
Mm-hmm.
T square plus 1. Now you can separate, you can use variable separable method. Okay.
Mm-hmm.
You can see this is terms of t and this is terms of x. After this, do integration. Integration of 1 upon 1 plus tan square is, you know, the integration of this,
Yeah.
and integration of
It's
1
tan inverse
tan inverse
x.
1 with respect to x plus c. So t will be what? Tan x plus c. And at last, put the value of t. Okay.
Yeah. Mm,
This is your answer. C is any arbitrary constant.
Wait, I don't get how you got dt over dx minus 1 equals 2 squared.
T, when you replace with T, you will get T square, right?
Yeah, that part I get.
तो dy by dx की जगह तुमको क्या मिल रहा है? So I here replaced dt by dx minus 1 and here we
Oh,
replace t. So when you replace the variable, you have to also replace dy by dx.
okay. Okay, yeah, got it.
Right? Okay.
So,
See,
x plus y equals t.
yeah. Let's suppose x plus y is equal to u. Any variable you can say t, u, v, anything. Okay, no problem. So derivation of x is 1. This is what? Dy by dx. Okay. So dy by dx becomes, right? Okay. After this, cos c. 1 plus cos c, right? Right? Yes. After this, what will you do? Integrate on
I
both
will.
sides. Yes. And you know, whenever denominator have sin or cos, you know, cos is replaced by, you remember this method?
Mhm.
And at last put t is equal to sin x by 2. Okay. तो ये कौन सा मेथड है? Whenever denominator comes in this form for integration. Okay.
Sin x is okay.
So cos x is replaced by 1 minus t square upon 1 plus t square. Sin x is replaced by 2t upon 1 plus t square. And dx is replaced by 2 dt upon 1 plus t square. So here you can write what? 2 dt upon 1 plus t square. 1 minus t square over 1 plus t square. And right hand side have no issue. Okay. When you simplify this, you will get integration of 1 is x plus c. Minus t square plus t square cancel. Okay,
Yeah.
and 2 cancel.
Yes.
2 to cancel, you will get 1 dt x plus c. Integration of 1 is t, and the value of t is what?
The value of t is
Tan x, not x.
x.
This is u. Okay.
Yeah. Value of t is 10.
Yes. X plus c. This is your answer. Oh no. At last, put the value of u also. Right. So final
Yes.
answer I am writing here.
Okay.
Okay. See this example. Okay, this question. You have given dy by dx is equal to, let's suppose I am writing 3. Okay, this type of question we have done, right? I am doing this question, third one, right?
Yeah.
You cannot separate x or y.
You can also put x or y.
Even you can separate, but there is no advantage of separating. Why? Because plus 1 is there. So in this case, what will be considered? Consider x plus y is equal to v. dv by dx becomes 1 plus dy by dx. Okay, so here we get plus 1, right? Minus 1 plus 1 cancel. Okay. Now you can integrate. Okay. Put the value of v. What is v? Okay. This is your answer. So you can also write x plus equal to c. C is a constant. You can even write minus c plus c anything. You can just write only c. Yeah. It's not about easy or hard. I will tell you different type of questions so that you can see the variation in the question. Understood? Understood? तो ये भी क्वेश्चन मैंने बता दिया है, ऐसा ही बता दिया, राइट? I give you some problem you can practice at home. Okay, one more question we can do. See, okay. So this is 4. Okay. So in this case, consider x upon y as a v, right? So here you can write y vx. Okay. Okay. Use quotient rule. V derivation of x is 1, x derivation of y is right.
Mhm.
Okay, or you can do like this. Derivation of x is 1. Use product rule. B, derivation of
Mhm.
right. So here you will get 1 minus y dx into 1 over b, right?
Mhm.
So I write here 4 minus b. Okay.
Mhm.
Multiply b on both sides. But one problem is there. Still y is not eliminated, right?
Mhm.
This is actually different type of problem. This is homogeneous problem. So in next section I will explain how to solve homogeneous problem.
Mhm.
Okay, this is not variable separable problem. I think you understood variable separable method, right?
Yeah.
Okay. So next time we will discuss homogeneous problem. Okay.
Mhm.
So we can meet on next time.
Okay. Thank you.
Okay.
Bye.
Do you have any problem today? You understood?
No. Understood.
Okay. Okay. Sending you the video of today's lecture.
Mhm.
Okay.
And the homework questions
Yeah,
also.
I will send you homework question also.
Mhm.